Okay, so explain whether the triangles are similar. So in order to prove similar triangles, the only thing I need to do, well, it was working right before I hit record, my little tablet pen. So to prove similarity, there you go. Similar triangles, we only need to prove that two angles are congruent. Well, that's not a very good S.
Oh, wow. Wait. Oh, no. Is that a 2? That's a 5.
Now, when you see an equal sign with a tilde, that means congruent.
Oh, what? No, it's tilde, not a tilde. I thought.
I love it when kids try to correct my pronunciation and they're wrong. Well, who said, somebody, I said boombastic, and they were like, it's boombastic. I said, no, technically.
Bombastic!
Yeah. Anyway, you guys are wrong. So, let's focus on the math. So, in order for me to prove similar triangles, I just need to prove all three angles are congruent, but because a triangle, all three angles have to add up to 180, I really only need to prove two, because if two of them are congruent, the third one, because of that sum of the interior angles has to add up to 180, we know that all three are. So we really only have to prove two. So I have some angles here. This one's 30. This one's 109. I basically got to figure out what D is, and I have to figure out what angle B is. Now, if I want to find out what angle B is, the measure of angle B is going to be 180 minus the sum of these two. So if you guys have a calculator, you just take your calculator out. Let me turn my calculator on. I'm telling you right now, you guys need to settle down on the talking. These little side conversations and cracking jokes are not beneficial to the learning process. All right? So just be quiet and settle in. If I take 180 and subtract the sum of these two angles, in other words, I'm going to add 41 plus 30. Now, I know it's 71. Okay, I know that. I know I could subtract it, blah, 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 blah. But I want to show you how to set it up and do it the correct way every time. So when I do it that way, I get that this angle right here is 109. So if this angle is 109, well, there I have it. This is 109, this is 109, this is 30, this is 30. So I've proven that they're similar. Okay, and when you look at them, ABC clearly looks like it's bigger than DEF. So now if I wanted to verify D, remember that the measure of angle D is just going to be equal to 180 minus the sum of 109 plus, that you can't see that 9, can you? We'll write it this way. The sum of 30 plus 109. Okay, and so I'm going to plug that in the calculator real quick just to make sure. We know that it's 41, but let's just make sure, okay? So I'm going to say 109 plus 30. Yeah, it's 41. That makes sense, right? So then this is 41. So the measure of angle D is 41. Okay? And so from that, we know that ABC has angle measures blank, and DEF has angle measures blank. What do you think we put in the blank there, you guys? What were some of the answers that you guys put? Just put numbers? 180. But hold on a second. You just put 180? Is there a better way to word that? DEF has, I mean, do you think we just put 180 in there? Well, I'm just curious. I think what we probably, so let me let me clarify where I'm trying to go with this. Remember, we're trying to prove that the angles are congruent. Now, if I say 180, that doesn't prove that they're congruent, right? So I need to prove that they're congruent. So why don't we just write out what the actual angles are? So A, B, C, and we put them in order. If this goes A, B, C, we write them in the order that it's presented. So A, the measure of angle A is 41 degrees. And the measure of B is 109 degrees. And then C is 30 degrees. And then DEF, guess what DEF has? Well, if you follow D is 41, comma, E is 109, right? F is 30. And so then we say because two angles in one triangle are congruent to two angles in another triangle, the triangles are similar. Now, it doesn't prove congruence, it just proves similarity. In other words, we know that they can be proportional and they have a scale factor. Now, the scale factor could be 1. I mean, that is a possible scale factor. That would make it congruent. But when you look at this, you can see that DEF is a little bit smaller than ABC. Okay? So now that we know that, let's try to do this problem. What I like for you guys to remember on these problems, though, and I always sketch them out. It just, for me, it makes it easier to draw the big triangle like this. And then I draw the little triangle separately. And you could just sketch it out. It doesn't have to be perfect. Mine isn't perfect. And so when it says the flagpole casts a shadow of 23, I'm going to change to a darker color too. Let's change to blue. When it casts a shadow of 23.5 feet long, at the same time of day, Mrs. Gilbert, who is 5'5", casts a shadow that is 7.5 feet long. And how tall is the flagpole around your answer? So I'm looking at the big triangle and the small triangle, right? The flagpole, we don't know. That's H. So this is where I'm going to do the sides of the big triangle. Well, what's the length from here to here?
Wait. 16 minus 7.5, 8.5, I don't know.
How do I find that? What's the length from here to here? I need this, the length. What I'm really trying to figure out is what is the length from here to here?
23.5.
How'd you get that?
I added 16 and 7.5.
Okay, so I'm gonna write it out. 16 plus 7.5, which if you add it up, it's 23.5. Okay. Now, what is the measurement of this side length here? 5.5. What is the measurement of this length here? 7.5. So the things that correspond to each other we have to write. So H is the big triangle, and 5.5 is the height of the small triangle. So when we look here, I have 5.5. Which triangle is that? The small one. So we have the small ratio set equal to, what's the H? What triangle is that? The big one. So I have 5.5 that represents the height, and that's the small triangle. What's the other side on the small triangle that I know the value of? So I'm going to put 7.5 here. Is that the only way to set it up? No, we can set it up another way, but this is the way that they started. So now what side length on the big triangle corresponds to the 7.5 length? 23.5. Now, can I plug any number in there? Yeah. If I accidentally plugged in 16 and forgot the 7.5, would I get an answer? Yes. Would it be right? No. So you really got to stop and think and pause and make sure you're getting the right answer. Now, if we want to solve this with proportions, you could do what we call the bat and ball method. In other words, I can cross multiply this and then divide by this. So I could say that H is equal to let me do it like this. 5.5 times 23.5 divided by 7.5. And so we'll just do that on our handy dandy calculator and see what we get. So in parentheses, I'm going to say 5.5 times 23.5 divided by 7.5. Oops, not 2, 5. And I get approximately, if I round that to the first decimal place, let's just call it 17.2. That's it. Okay. How many of you guys got 17.2? Raise your hands. Okay, good job. All right, let's move on to the next one. It says, two transversals intersect two parallel lines as shown. Explain whether ABC and DEC are similar. So we've got two triangles, okay? We've got one triangle like this. And I'm just freehanding this. It doesn't have to be perfect. This is ABC. And I've got another triangle like this, which is CED. Now, when they put them in order like this, A corresponds to D. B corresponds to E. C is supposed to correspond, C is supposed to correspond to C. So we got to keep that in mind. So if I can prove that those are congruent or whatever, that's fine. So how do I prove congruence? Well, BAC, this angle here is well. Wait, let's do that differently. Let's use the color. BAC is congruent to EDC, isn't it? Why is that? What type of angles are those? Yeah. Since they are alternate interior angles. ABC, right? ABC and DEC, in other words, this angle here, and DEC and this angle here, those are also congruent since they are also alternate interior angles. So if I have two angles, what do I know about the third? Yeah. But there's a new theorem that we're working on too, and we've been working on it, but we haven't loosely identified it. It's called angle-angle similarity. So we could say by a similarity, in other words, if we prove two angles are congruent, then the triangles are similar. So by a similarity, that's the word similarity. Oh, that's terrible. You guys can't read that, can you? Maybe I should type it.
I can't read any.
Yeah, let's just type that. So I'm going to say a similarity so you guys can see it a little better. Oh, I got my that's funny. I put my little the little stylus pen on my tablet, and I kept trying to use my mouse, and it wouldn't move because this was on the thing. Anyways, that's funny to me. So that means that triangle ABC and triangle DEC are similar. Okay? So then the last one is, how can you determine when two triangles are similar? Well, if two triangles are, let me see. I think I'll just type that too because it looks nicer. Let's just type it. If two angles of one triangle are congruent to two angles of the other triangle, I gotta spell the words right, of the other triangle, the triangles are similar by the angle similarity postulate. And I'll explain the difference between the words postulate and all. And let me make this a little bigger too. Okay, there you go. So let me repeat that because it says, how can you determine if two triangles are similar? Well, one way, there's many ways, but one way is if two of the angles of one triangle are congruent to two angles on the other triangle, then the triangles are similar by the angle similarity postulate. Now, the difference between words like postulate, theorem, and axiom is like stages. A theorem is like the highest stage. It's something that's existed forever, and we've never been able to prove it wrong, right? It's almost like when you think of science, there's like a hypothesis, and then there's a law. The same thing, math kind of does the same thing, right? So a theorem is something that we consider to be proven, and there's no way to prove it wrong. Postulate is just a little bit lesser, although some would argue differently. And an axiom is something that we don't necessarily prove true, but we assume it's true because we weren't able to prove it wrong. It doesn't matter. Just get used to those words. If you ever become a math major in college, those three words do have slightly different meaning, but basically they're some sort of, for your sake, there's some sort of representation of something that we hold to be true. Okay? Yes? Where does the property fall in that? Property? Property is something that we observe. So, yeah, that's a great point. Yeah. Boy, that's good. That's a good discussion. Let me stop the video and we can have the discussion. Anyways, your homework is posted. You can work on that.